Ace Podcast.
Hey everyone, welcome to Vaguely Accurate. Happy New Year to you all. I'm your host DK, and today on the show we'll be meeting Vish, an aerospace engineer who just completed his Masters from RMIT University in Melbourne, Australia. I won't ruin too much, I'll just say that if you check out the website, you'll see his end product, which was a 4-propped propeller drone. It's really impressive. It's about a minute long, the video, and it's both entertaining and pretty awesome to watch. So I suppose let's get into it.
Well, my full name is Vishwakant Brahmaya, just Vishwa for short. I actually finished the Master of Aerospace Engineering at RMIT just like a few weeks ago.
Congratulations.
Yeah, the marks just came out today, so I'm officially finished.
So you're feeling quite relieved?
Yeah, definitely. Just got to find a job now.
Not exactly the ideal thing to be doing in this market. Could you define to us what is aerospace engineering?
Okay, aerospace engineering basically is the science of like designing and building an aircraft, anything from a drone to rockets. But we do mainly learn about wings and engines basically in the university. So basically we start off studying about basic physics and maths in our first year, and then as we go up we learn more about how to design a structure, how aircraft structures work, propulsion and aerodynamics. That's what it divides into. And yeah, aerodynamics is mainly how a wing would create lift and lift up the aircraft.
Yep.
Being a propeller or a like helicopter rotor. Propulsion is jet engines we learn about, and also propellers. And in structures we learn about how to build design a strong structure.
Do you find there's a lot of modeling involved?
Yeah, definitely. We do a lot of 3D modeling, and 3D modeling of structures also, and also we do something known as CFD, or computational fluid dynamics. And we have software that actually can, simulate real-world airflow, and yeah, that's how we can estimate the performance of wings and engines as well.
What got you into aerospace engineering?
Well, I always had a knack for engineering. Well, I liked fixing things since I was a kid, but thinking back, I always used to see traffic everywhere back where I grew up in Bangalore, in India. And I always thought it would be good if you have something like an air taxi or something like that to skip the traffic,
Yeah.
And that's basically why I inclined towards aerospace. And yeah, I never thought of any other field to study. Actually, it's just stuck in ever since year 10. I knew I was going to become an aerospace engineer.
It's taking a bit of a move on. What exactly was the title of your project and what did it involve?
Well, the title was Dynamics and Control of a Amphibious Vertical and Takeoff Landing UAV. I basically built a drone that looked like a normal plane, but also took off and land like a helicopter. It didn't really fly that properly, but it did take off. It's good. But yeah. The concept is for border patrol for countries like Indonesia, where you can't actually land everywhere because there's a lot of rainforest. Terrain's really wonky and there's no plain surface. So if you have something that lands like a helicopter, it's easy. And if you have fixed wing, like normal plane, you can do high speed. That's why we need to check if we could incorporate those together.
Yeah. So you had to build a model for your project, right? Are we able to get a picture of the model later on just to put on the website?
Yeah, definitely. I can.
That'd be great. Because I mean, you said it's structured like you're looking at the structure of a remote UAV you made that takes off vertically and lands obviously vertically as well, but it's structured much like a normal plane. So did you have to make any adjustments to? I mean, you said it didn't fly well, so I assume it was that because it was modeled directly as a normal plane. Would you have to make more aerodynamic adjustments?
Yeah, basically the modification was we just got a small RC plane that's meant for just normal flight, like you just throw it and then control it. Doesn't really land. Well, you can modify it to make it land like a normal plane as well, but that's the basic model we got. I got motor on each wing tip, the tails as well. And I did a lot of modifications so that motors at the ends could be controlled to like tilt.
Okay, yeah.
Yeah, that was basically the whole semester, like getting to modify, like just cutting pieces of foam, putting back together. Yeah,
Sounds like a fantastic course to be doing. Like you hear about people spending all their time in front of a computer just trying to delve down into that, and then you're sitting there making these remote control planes.
Well, I actually had a lot of fun.
So the research component was more looking into the practicality of designing a model and then using that model to build practical applications into a real world scenario.
Exactly. So we had to use the model to, basically validate the life-size concept.
How accurate is the when you've made the model using a drone? How accurate is the drone in regards to manipulating its structure? Does it respond well to changing that?
Yeah, that's one of the reasons it didn't fly, because the structure we got was really flimsy, especially the tail. Tail boom just is a single rod, basically a hollow foam rod that's about 3 or 4 centimeters in diameter. And yeah, it was basically weak, and when the propellers are given power, it just starts shaking, and which makes the front propellers also go bad. But yeah, after that, I actually got a flight controller. All drones actually are meant to use a flight controller, no matter how small they are. Otherwise, you can't control them. But after I got the flight controller, it was a bit better. But I needed more time to program the controller and make make it fly properly. But I didn't have enough time to do that. It just takes off. I had to give it back.
So did you have to, like, your project itself was building, you're looking at the vertical liftoff and takeoff of a standard aeroplane, and you've described before the internet flaked out, that you, the model itself was a standard drone designed to look like a normal typical aeroplane with propellers on the tips and on the tips of the wings and on the tips of the tails. What is the practical application of having that? You said that they're used in Indonesia, but why would they be required to just lift off vertically or not?
Well, they're not used in Indonesia yet. This was actually to check if it would be good for Indonesia. Basically, the idea is that because Indonesia doesn't have, like, most of it is covered with rainforests, and the terrain is not even. It's all mountainous and rocky and uneven. So basically, to make a flat runway where a normal airplane can take off and land is really hard. Like, you can make it in a few places, but not everywhere. But obviously, you need to patrol the whole border, and not in just some places. So a fixed wing, so a normal airplane that can take off and land vertically, can its advantages both in terms of speed, because a normal plane flies faster than a helicopter, and also you have the capabilities of helicopter to land anyway. If there are any issues anyway in the border, you can just land there and then take care of the issues. That's the idea, how it would benefit.
What is the benefit of having 4 propellers as you've designed it, as opposed to the typical 2 propellers that are already in operation?
That's what another part of the project was. Most of them use 2 propellers, but we thought, like, if we have 4, we can distribute the weight more evenly, which would mean we could use a bit smaller propellers at the front. By distributing the weight evenly across the plane, you can control it better, and also, structural wise, it's more sound as well.
So I suppose what's next for you? Like you said, you're going to plan to try and get a job in America. As an aerospace engineer, are there 2 different divisions of jobs, or maybe even 3? Something that's more practical and designing, as opposed to a more computational position?
That's it. As I said before, you can get, so basically there's 3 fields: aerodynamics, like basically the physics behind aircrafts. There's structures, which you would design structures, and there's a lot of involved in designing structures as well. The third one is propulsion, so you can get into designing engines, so like companies that make engines. But yes, mainly that. Also, you can get into the software part, like a lot of companies that just specialize into the software that runs the aircraft, and aircraft maintenance as well. Yeah.
What is it that you wish to get into?
Design. I want to design aircrafts.
Yeah.
But I have interest in like propulsion as well. But in the end, I just want to work on making basically mini aircraft that can work as a taxi.
An air taxi. Is that what you see the, I suppose, future of aerospace engineering to go, rather than have, you got driverless cars and then you can have an air taxi?
Yeah. So the driverless cars, the concept of that is really, really important, especially when it comes to air taxi, because if at all there is going to be any concept of that and real implementation, it has to be autopiloted, because not everybody can get a pilot's license, and you know how the people drive on the road, right?
Yeah, that's true.
But no, it won't be like that, but most probably will be automatic, or like autopiloted aircrafts that just drop off people and pick up people.
So this would be like air Uber.
Yeah, exactly.
Yeah.
Without a driver. I see this as a way of solving the traffic problem. If you have a taxi, just let's say to go from the suburbs into the city for work, basically a supplementary form of public transport.
That'd be absolutely fantastic. I'm imagining, I think it's in Star Wars 3, like the Air City, like where Obi-Wan Kenobi's kind of falling through the sky towers and just try and land on the air taxi as you've just described.
That's the one. That's what I want it to be like.
That'd be incredible.
Yeah, I wouldn't say the industry is tending towards that kind of thing, but in the coming years you'll see a lot of things happening.
Do you have any messages for anyone that may listen to this?
Well, basically, at least aerospace engineering, it's hard to get a job. I'll tell you what the head of defense recruiting for engineering said when he came to the industry. He said 3 main things are the distinct characteristics that step out from people who get a job in the industry and people who don't. One thing will be motivation. You got to stay motivated no matter what, and you can see why. Second one is attitude, and the third one is enterprise skills. If you want to get a job in the industry, you just got to keep trying.
Keep trying. Be persistent. Yeah, no, thank you very much for your time, man. It's really good to have someone like you on the show.
It was good to finally meet you face to face as well.
And that's our show for today. Thank you everyone for listening and tuning in. If you have any questions about the episode or would like to get in touch with us, as always, you can via any social media or our emails at vaguecomments@gmail.com. If you yourself or anyone you know may be interested to come on the show, again, encourage them to contact us. Like, we're friendly, we don't bite. Definitely check out our website, vaguelyaccurate.com, and on there you should be able to find Vish's video of his drone taking off. It's quite cool. I wish I had the skills to develop something like that. But then again, I suppose that's why you go to university to improve on those. And as always, check out acepodcastnetwork.com. Ace Podcast Network is just a friendly community where everyone joins together and helps each other. It hosts a large array of shows, and to celebrate the new year, we have two new shows coming onto the network: Crossover University and Aussie and the Pom. So if any of those resonate with you, check them out. Alright guys, as always, take care, and I look forward to hearing from you, and check us out next week. Bye.
Can you hear me now?
I can hear you.
Is that better or is the other way? I think the other way is better.
The audio is better. I can definitely hear you.
I think that was my battery going. Connect your charger.